Good evening, everyone. I welcome you all in this session of SAS. And to begin with, let me quickly get a confirmation from you all. If you are able to listen to the voice clearly, just let me know on that. If you are able to hear, if you are able to listen to the voice clearly, just let me know on that. Yeah, so I would be checking up the comment box. And in Pune, it's heavily raining, so we cannot expect um, the electricity to be, more cooperative with us, or the internet to be more cooperative with us. But still, because we planned this session, we will have this session, and I would like to formally welcome you all in this particular session of forecasting and time series using SAS. So, how's the Josh? Let me get the Yeah. Okay, great. Let me get some comments out here. How's the Josh to attend this particular training? Okay, so I'll have to put on my another device. Meanwhile, you can quickly ask everyone to join in your friend circle in your network so that all of them can get the benefit of this particular session. And yes, so we are starting without putting much of the time in any other discussion. So this session will be divided into two parts. Listen to the instructions carefully. It will be divided into two parts. The first part will be of basics, fundamentals, because I'll be telling you that how you can set up the SAS and how you can start programming with it. And after that particular session, we will directly jump to the time series and forecasting. And I'll take up a data set. I'll tell you the whole steps, whole process, and we will walk through with practicals doing along. So that is how we'll be doing. So be ready with your laptops. If you have not basically connected with your laptop, then I would request you to kindly get connected with your laptop, because that is going to really help you out. So do connect with your laptop. And meanwhile, I'm just sounds. I need to disable the sounds over here. Okay, all right. Yes. Okay. So now let me share my screen. We are starting now. So you need to have your laptops along so that you can directly work along with me. Okay, so I hope my screen is visible. Can you please confirm, everyone, if you are able to see the screen? This is the first session. First session means there are two sessions. This is the first session. Okay, so SAS setup and programming. Let us now move ahead and try to understand. The agenda of this particular session would be we'll try to understand the SAS environment, user interface, program structure, basic syntax, datasets, variables, strings. And there are so many topics in this particular presentation, but I would try to take it up to 40 minutes or 50 minutes at max. So whatever we will be able to cover up so that you can get started with SAS. Let us now begin. So the topic number one is SAS environment. So SAS Institute Incorporation, they have released a SAS University Edition. Now, initially they released SAS University Edition as a virtual machine. So what you need to do is you need to have a virtual machine, and you can download from the SAS website the University Edition, and you can open it up with the help of Oracle VirtualBox, and you can start the SAS software over there. That was one of the options we had. But later on, what they did, they basically came up with another thing, which is SAS on demand for academics. So now what exactly is SAS on demand for academics, and how is it is better from the previous one? The good thing is that you don't need to download anything. You simply need to go to a particular link and just click on it and create your profile and log in. That's it. You have to do it. I'll explain you with the help of the presentation. Then I will show you that how can you do that. So let's start. Now, SAS on demand for academics. or you can say Soda, is a cloud-based SaaS software that runs on a browser. So that is what I'm talking about. And unlike SAS University Edition, you don't need to run software on a virtual machine. That's the benefit you are getting over here. Now, simply create an account with SAS, and you can get the access for the software free within a couple of minutes. So only in couple of minutes, you are going to get the access to the whole system. So yes, you can understand that SAS University Edition has been discontinued and it is replaced by SAS On Demand for academics. This is how the screen looks like. So what you need to do is first you need to go to the product page of SAS On Demand for academics. Next, you click on the access now. Here you can see we have on top and we have here also access now. So if you click on access now, then it'll allow you to put your ID and password. But if it is for the first time, if you are doing it for the first time, then you don't have an account. So what you need to do is you need to click here, don't have a SAS profile. Just understand. Okay. And you can keep on following with me. I'll tell you that even if you miss out something, if I have moved ahead, so just go back, like just move the video to the to back in time and watch that again and do it. So you can do it live. All right. So yes, so in this chapter, we are seeing that how we can create the account and how can we get the access to SAS environment. So here you can put your ID and password if you already have your SAS account. If you don't have, then click here, don't have a SAS profile. So once you click on this, don't have a SAS profile, what next comes in? Next, you have this particular form which pops up, which you have to fill it. And then after that, you will be able to get that particular account created. Okay, so here I have given a link also, www.sas.com/profile UI has create. You can type in and execute, or you can go to the SAS website, www.sas.com. So you can go to the SAS website as well. Even there you can get it. Okay. Next, what you need to do is you need to activate your SAS profile. So in order to activate your SAS profile, you will receive an email. So you need to understand that you have to put the email correct. You don't have to put a wrong email over there. So put the right email so that you can get an email on your account so that you can click on this particular activate your SAS profile. Once you click on this activate your SAS profile, then what is going to happen? It is going to basically ask you to set your new password, or it may not ask. So if it is asking, then set the new password. If it is directly allowing you to log in, you can directly log in. Okay, so you can put the password over here and then you can try login. Follow the rules, whatever rules are there, 8 characters, one lowercase, one uppercase, one symbol, one number, just follow the rules. So most of you, if you are from IT background, you know these things. If you are from non-IT, because I know people from pharma, people from management, even those are here. So yes, I would say that what you can do is you can basically follow what I'm saying, the guidelines and directions. Okay. Once your account is created, then basically you just need to sign in like this. Okay, so you can go to the link I have given in this particular slide. Just have a look at this, HTTPS. So have a look at this. I'm just annotating it so that it becomes easy for you to have a look at this particular, yeah. So here you can see this one. So you can just click on this https welcome.oda.sas.com/home. So here you can click and or you can type in and you can basically directly go to the website where you can log in. So let me clear the screen and move ahead. So now what next we need to do is, so this kind of screen will appear and you have to type in the password, ID and password, click on sign in, and then you'll be able to launch, okay, your SAS environment. But for the first time, if you are doing it, in that particular case, there is something you need to do. And what is this? This is that you need to select one region. So you can select one region. You cannot do it later on. So just select one region. I have taken Asia Pacific. So wherever you stay, you can choose that particular region. So once you have taken that particular region, what is next? Next is basically you will again get one email. And once you receive the email, you will see that it will give you the link that from this particular link, you can always sign into the SAS environment and you can work on it. Okay, so once again, you'll have to put the ID and password, and that's it. and SAS Studio is there. You can click on it, and or you will get a launch icon. You can click on launch icon and you will be able to log in. So let me show you that this is the screen which will appear. So now I'm going to show you that how does all that happens. So once you click on this welcome.oda.sas, okay. So before this also, if I go for this SAS.com, so I'm going to SAS.com. So here you have to understand that every time what SAS can do is SAS can always keep on changing the UI, some processes. So all that basically SAS can do. So don't worry about it. So here you can see this is SAS website. Explore it for more information about SAS. For example, with SAS VIA, VIA is a new product they have. And with SAS VIA, there has never been a better time to be a data scientist. So every company we know that they do marketing and they do a lot of say good thing about themselves. Okay, so I'm not saying they're not good. They are good, but this is something everyone says, so you can explore this thing. So I want to learn, so I can go here and I can basically check on different things. If I go for software here, if I see, can I get something which I'm looking for? So I'm basically looking for SAS for academics. Okay, SAS on demand academics. So you can directly type in that also, SAS on demand academics, and you will get that. So here SaaS products and services are given. So we are on Azure, everything, capabilities. So so here you can see a lot of, so we will see, we'll come to this particular part. So I'm just going to a new tab, SaaS on demand, DEMAND for ACADEMICS. So if you are typing it for the first time, so this is something SAS on demand for academics. You will get this particular thing and where you can make the registration. So here you have access now button on the top, and here also you have access now. Click on this access now. After that, this particular screen is coming up. So if you will click on sign in, it comes as this, and you need to click on don't have a SAS profile. It will give you that particular form. Here you can see that we are going to get the form. Yeah, it is coming up over here. Yeah, so this is the form. So fill in this form and then create your profile. Okay, so I hope this is clear to everyone. Now let me close this private window, and here I need to click on sign in. So sign in, and it is asking me for ID and password. I'll be putting in my ID and password. And after that, you have to click accept the terms and conditions, then sign in. So it'll take you to a home page from where you can go to your SAS environment. You can do it along with me. And as I said, you can always move back to the video and again follow the same steps if you are not able to follow it. So here you can see this is the environment of SAS. So here you can see this is the environment. So let me show you that how things are happening over here. So it is getting signed in, it is signing in over here, and it may take a couple of seconds to get signed in. And meanwhile, let us go back to the presentation and understand more from the presentation itself. Okay. So once you are able to sign in, then you have to click on this SAS Studio. And so the new interface I'll show you, there we have a launch button. So you can click on the launch button. And after clicking on the launch button, you will get this kind of environment. So this is the environment of SAS. So here I'm going back. So it is still signing in. And let me just refresh this particular screen. And I'm again clicking on sign in because there is some internet lag over here. So ATA, and I need to just put the password over here and let me sign in. Okay. I hope now this should be quick. Yeah, so here you can see this is the window, and now we have a launch button over here. So earlier we had this particular SAS Studio kind of thing. Now we have launch button. I'm clicking on launch and it will be launching the environment for me. So here you can see it is launching the environment for me. So what we will get is we will get this kind of interface, and this is opening a successful setup of the SAS account, and we are able to access the um, SAS window. So here you can see this is the live window in front of us. Let us try to explore this window. Meanwhile, you all are creating your accounts. So let us try to explore this window. How can we do that? Okay, so on clicking SAS, Start SAS Studio or the launch button, we get the SAS environment by which default opens up visual programmer mode as shown below. So here we have two modes. Here you can see we have SAS programmer mode and visual programmer mode. So this one you can see this is a visual programmer mode. If I click on here, and I click on the SAS programmer, this has opened up as a SAS programmer mode. So two modes are there. What is the difference between them? SAS programmer mode allows us to write the code over here. You can see I can write the code over here. And if I go for visual programmer, so in that particular case, I can create components from here. Let's say I want to create a SAS program. So this is a component, a SAS program I'm creating. So we are actually going to work on SAS programmer because we need to know a bit of coding as well, how basically we code in SAS. Okay, so let's go back. We can also change it to SAS programmer mode by clicking on dropdown that we have seen. What SAS stands for? SAS stands for Statistical Analysis Software. It was used for data management, business intelligence, predictive analysis, descriptive analytics, and prescriptive analytics, etc. Since then, like since the time SAS has become popular, many new statistical procedures and components have introduced in the software. Let us move ahead and try to understand. SAS is also platform independent, which means that you can run it on any of the platforms. What SAS provides us? So SAS actually gives us a lot of things. With the help of SAS software, you can perform various operations like data management, statistical analysis, report formation with perfect graphics, business planning, operations, research and project management, quality improvement, application development, data extraction, data transformation, data updation and modification. So many things you can do with the help of SAS. Let us move ahead. What are the components of SAS? So we have seen in the website also. So base SAS is there. What we are actually going to use, it is a core component which contains data management facility and a programming language for data analysis. It is also the most widely used. Then we have SAS OR. OR basically stands for operations research. Then we have SAS Insight, which is for data mining, SAS VIA for high performance AI and analytics platform. Then we have SAS Graph, and this SAS Graph is basically for creating graphs, presentations, and better understanding and showcasing the result in a proper format. Then moving ahead, we have ETS, SAS ETS, which is econometrics and time series analysis. Then we have SAS PH. SAS PH is used for clinical trial analysis. Then we have SAS Stats, so perform statistical analysis with the variance analysis, regression, multivariate analysis, survival analysis, and psychometric analysis, mixed model analysis. So for that, we have SAS STAT. Then we have SAS AF, which is for applications facility. Then we have SAS Enterprise Miner, which is for data mining. So there are different types of SAS softwares. We have seen applications, so Windows or PC. What we are going to use is Windows or PC SAS. Then we have Enterprise Guide, Enterprise Miner for predictive analysis. SAS means SAS Stats. So we are going to use Windows SAS. Windows SAS, this is something if we download that particular uh, the virtual box. Okay, as of now we are using on server. Okay, so we have what all things do we have in the SAS window? So here you can see we have a code window, we have a log window, we have a result window. So what does this log window does? So this log window is like an execution window where we can check the execution of SAS programs. So if you click on log here, there are no basically logs. So if I click create something, PROC, something I write here, and after that, if I execute this particular program, then in that particular case, you see some logs have been created over here because it's not the proper program. So it is saying it is a syntax error. It is not a proper program. So there is a syntax error over here. So this is the log window. So understand that in this window, we can check errors also. It is very important to check every time the log window after running the program so that we can have proper understanding about the execution of our program. The next we have is editor window. So editor window is a part of SAS where we write all the codes. It is like a notepad. So this code, this is the editor window where we can write our programs. And then we have output window. So this result is the output window where we will get the output of the code, or result window. They're same thing. Output window and result are the same thing as of now. So we get the results. So whatever results, and if you execute multiple codes, then you will get multiple lines here. Okay, so multiple outputs you will get. So result window, it is likely an index to all the outputs all the programs that we have run in one session of the SAS are listed there. You can open the output by clicking on the output result, but these are mentioned only in one session. So we need to understand that outputs are volatile over here. So output doesn't remain, like after you close it, it won't remain more over there. Okay. So explore window, here are the libraries. So you can explore the libraries. You can also browse your system SAS support file over here. So here you can see, you can explore the libraries and server files and folders. You can explore them as well. Now, in case of libraries, SAS has got two types of libraries. So what are the two types of libraries do we have? One is temporary or work library. Temporary basically means that, as I was explaining you, if you create a program, it actually enters into the work library. So this is the by default library of SAS. All the programs that we create are stored in this library if we do not assign any other library to them. You can check this work library in the Explore window. If you create a SAS program and have not assigned any permanent library to it, then you end the session. And after ending the session, if you again start the session, you won't find your program over there because it's temporary. That is what is the name, temporary or work library. Permanent, so these are the libraries of SAS. We can create a new SAS library by using SAS utilities. We can use the SAS utilities or by writing the codes in the editor window. These libraries are named as permanent because if we create a program in SAS and save it in these permanent libraries, then these will be available as long as we want them. So these are the two types of libraries. Okay, I think this can be a question which you can face during the MCQ. So yes, so I will keep on giving you the hint so that you know. So you will get, you may get an MCQ after this particular session that will be enabled, where you may get, okay, what are the two types of libraries? So you will have to take, okay, it may have options like temporary library or work library, permanent library, or maybe some other options would be there. So you have to take the right answers like temporary library and permanent library. Okay, so listen to the video, and when you are giving the assessment, you can watch back the video. That will be helpful for you. Okay, now let us move ahead to the second chapter, that is the user interface. So we have already started to discuss this. Now, in the user interface, SAS programs are creating using a user interface known as SAS Studio. So this is basically SAS Studio. Now, this window you see on entering SAS environment, in the left side, you can see the navigation pane and to navigate various program features. And on the right hand side, we have the work area, which is used for writing and executing the code. So this is what is the screen, and we are able to see here it's similar. Okay, this is a new interface and the presentation is having old screenshots, so just bear with that. Now moving ahead, the wonderful thing with SAS is it has got code autocomplete. So this is very powerful feature which SAS helps getting the correct syntax of SAS keyword as well as provide link to the documentation of the keyword. So for example, if I go to the code area and I start writing something, so let's say proc. So if I write proc, you can see that proc documentation is over here. So keyword is proc, and you click on it, it will open up a documentation where the description about proc will be given. So that is the benefit of having this particular feature. And let me now close this and go back here. If I click on procedure, it tells me about procedure. And then it has got product documentation, samples. So this will be a very great help, because as you start with SAS and you start programming with SAS, then you can keep on exploring these documentation, which will enhance your width as well as depth of the knowledge. So let me just go back to the presentation and let's move ahead. So program execution. So for executing the program, you have two options. One is this, basically a human kind of icon is there, which is running. So you can click on that running icon, then you can run your particular program, or you can just press the F3 button. Even that helps you up. So now there's a quick question. Let me know how many of you are successfully able to set up your SAS profile. Once again, I'm asking, how many of you are successfully able to set up your SAS profile? Give me a yes in yeah, in the comment box. So still some people are asking for links and all. So I would say that please pass the link to all of your friends so that they can quickly get into the session, and they do not lose anything when we are discussing in this particular session. All right, so now I'm moving ahead, and by moving ahead, let us now try to, yeah, so Okay, yes, I have sent the link to those who were asking. So let us move ahead and try to understand this program. So proc print data is equal to SAS help.air run. So this is how we need to write a program. So proc, and then after that, so initially, if you don't understand the syntax, just keep on following it and you will gradually understand the syntax. Okay, so that is basically an important part. Keep doing along with me and try to understand what you can. And syntax wise, if you have question why after proc print is written that way, so I will say syntax wise, just go with the flow. If the syntax says after proc I have to write print, just write print for some time. Okay, so once you write it multiple times, you will remember the syntax as well. Okay, so proc print and then data is equal to, so print print, and then data data is equal to SAS help and dot AIR air, and then we have next thing as run run and semicolon. So like many of the programming languages, we have a semicolon here as well. So this semicolon actually help us to understand that the statement has been completed. So understand, SAS also takes it this way, that once you complete, then basically you have to write the semicolon so that it understands that statement has been completed. So now you can click on this particular run icon. It is going to execute this particular code, and it has taken you to the results section where you can see we have a column observation, date, and air. So observation, date, and air. So these three columns are there. So it has basically loaded that particular data set, and it has displayed that particular data set to us in the results section. Log has created the logs over here. You can see some logs are created over here. There were 144 observations read from the data set SAS help.air. So these three sections we have seen over here. Now we will move ahead. So program log, we have already discussed. The log of the executed code is available under the log tab. It describes the errors, warnings, or notes about the program's execution. This is the window where you can get all the clues to troubleshoot your code. Therefore, I always say that whenever you are getting some sort of errors, always read the error properly, or if you have access to the logs, go to the logs and read the logs properly. If you're able to read the logs properly and understand from there what is the concern, what is the issue, then no one is better than you, because you will be wonderful troubleshooter. All right. So the third window we had seen is results window. The result of the code execution is seen in the results tab. By default, they are formatted as HTML tables, and therefore we are able to see them as a like they're looking nice. Okay. Let's move ahead, and now program tabs. So navigation area, this area is called as navigation area. So here you can see this particular area is known as navigation area. So in this navigation area, you can see server files and folders, tasks and utilities, snippets, libraries, and file shortcuts. So these options are there. So the navigation area contains features to create and manage programs. It also provides the pre-built functionalities to be used with your program. Now we have server files and folders. Under this particular tab, we can create additional programs, import data to be analyzed, and query the existing data. It can also be used to create folders and shortcuts. So here, if I want to create more files, I can just click here and I can click on SAS program. So you can see program 2 is created. So all the files, I can keep on saving it. So Control S, and where you want to save it, it'll get saved over here. So I'm saving it over here. Okay, under this, so I've saved it. Just click on this and save it. Yeah, so files home, I'm saving it over here. It is saved. So here you can see program1.sas has been saved. So you can save it this way. Okay, so under this tab, we can create additional programs, import the data to be analyzed, and query the existing data. It can also be used to create folder shortcuts. Then we have tasks. Okay, so here you can see we have tasks and utilities. The task tab provides features to use built-in SAS programs by supplying only the input variables. For example, under the under the statistics folder, you can find a SAS program to do linear regression only by supplying SAS dataset name and variable names. For example, here if I go for tasks and data, graph, map, statistics, under statistics, if I go for summary statistics or data exploration, so if I click on data exploration, I just need to select a data source over here. Okay, what could be the data source? So under the my libraries, I can have Afghan 2, and I have taken that particular data set. Okay. And here, no column has been populated. So not on the maps, I will take maybe SAS help. Under SAS help, I'm taking air data set. So which we are using under this particular discussion, we are using that. So here under air data set, so here you can see, okay, and classification variables. Okay, so date and air I have taken over here. Okay, and here you can see, let me see the code. It has generated some code over here, scatter plot and all. And so what we said is basically it just needs that I need to have some columns selected, and based on those columns, it will be creating up this was a task of data exploration. So data exploration is done with the help of visualization. So it has created different visualizations over here for date and air. So here we can see that. Okay. So this is what is the second one, which is task section. Don't worry, this is something I'm just showing you. You can have a good patience to explore it step by step, because our this first session is more about to explore the user interface, so that you are familiar with the interface, you know the tabs and all, everything you know. So this is the tasks and utilities section, which we have tab, which we just explored. So let me close this, and I'm not going to save it. I've closed that particular thing. And yes, so let me minimize this thing. Okay. So next one is snippets. So snippet tab provides features to write SAS macro and generate files from the existing data set. So if you want to write macros, like in Excel, you have VBA macros, you can do that in the snippet. So here you can write the macros and utilize those macros in your other programs. That is something you can do. So after snippets, we have program libraries. So SAS stores the dataset in SAS libraries. The temporary library is available only for a single session, and it is named as work, but the permanent libraries are available always. So we have discussed that libraries are of two types. One is permanent library and one is temporary library. So the permanent library are staying forever and ever. So if you want to save something, you need to save it in the permanent library instead of the temporary one. So here you can see we have libraries, and if I yeah, so here we can see work library. So this is the temporary library, and all of the libraries are permanent. So if you want to save something, you can save things in the permanent libraries, so that they are there even after you log out and you shut down the session. Then we have file shortcuts. So these are the file shortcuts option. So here we don't have anything as of now, because this tab is used to access files which are stored outside the SAS environment. So meanwhile, I should quickly check if you are getting my voice properly. You can say yes, voice is proper. Just write in the comment, so that I am ensured that you all are getting it in a proper manner. So this tab of file shortcuts is used for accessing the file which are stored outside the SAS environment, not in the SAS environment. So for that, this particular option is there. Now, this is the end of the chapter 2. Now we are moving ahead towards the chapter 3, and this is program structure. Okay, thanks a lot for the input. And at the same time, I would like to ask, you can write same page. If you are able to follow me till this particular point of time, please write same page. Thank you. Thanks a lot for being with me. So now we are on the chapter 3, and this particular chapter 3 talks about the program structure. Okay, now program structure basically involves a couple of things: a data step, a proc step, and the output step. So three steps are there. So SAS programming involves first creating and reading the data set into the memory. So what is the first step? The first step is about data, because it is a statistical tool, an analytical tool. So for statistics, for analytics, what is the first thing do we require? We require data. So therefore, you can see that the SAS programming involves first creating and reading data set into the memory, and then doing analysis on this particular data set. So we need to understand that the flow in which a program is written. So here you can see I'm sorry. So here you can see that we have a data step, we have a proc step, and we have an output step. So the below diagram shows the step to be written in the given sequence to create a SAS program. The data step to create a data set that becomes the source of data analysis. Then we have a proc step. So this is actual where we do the analysis of the data, and then output step, which shows or stores, it shows, displays, or it stores the result of the proc, whatever analysis we have done. So every program must have all these steps to complete the reading, the input data, analyzing the data, and giving the output of analysis. Also, run statement at the end of each step is required to complete the execution of that step. So let's move ahead and try to understand further. So data step. So this step involves loading the required data into SAS memory and identifying the variables. The variables are also called as columns, because if you see in Excel, we have rows and columns. So the columns are actually called as variables over here. So of the data set. So it also captures the records, also called as observations. So one row is called as observation or record. The syntax for data statement is as below. So here you can write data at the beginning, you can write data and you can give a name to it. So data set name, and then input variable one, variable two, variable three, then create a new variable. After that, label, and then data lines. After the data lines, you have to actually put all the data. This is one of the option how you can create the data. So in the next slide, I'll give one example. So here is the example, a simple example of naming a data set, defining variables, creating new variables, and entering the data. So let us do this. Let us do this. The first program. So those who have done the login, please come on your SAS window and you can do along with me. आप मेरे साथ साथ चल सकते हैं. So here, data temp. So let me write data tmp temp. So what is happening here? So we are basically writing data temp. So what is temp? Temp is the name of the data set. So data set is named as temp as of now. Here, the string variables have a dollar at the end, and numeric values are or variables are without dollar. So basically, if ID is a string, then I have to write dollar. Name is a string, then I have to write dollar. So we have to write that particular way. We need to write that way. Okay. So I'll write input ID name. I'll not write so many. I'll just write three: ID, name, and salary. That's it. Okay. So I'll write input, then ID, put a dollar because I want it to be string, and name, and again a dollar, then salary, SALARY, salary. That's it. So I just want these three things. So input, ID, name, and salary. Now a special variable has been created. Okay, new variables, that is commission. So commission is salary into 0.25. 25% is commission. COMM commission. I'm typing over here, and the commission is, what is the commission? Commission is equal to salary into, yeah, SALARY, salary into 0.25. Enter. Okay. Now, labels, if you want to give labels, you can give labels as well, like label ID will be called as employee ID, com will be called as commission. So you can give labels as well. So LABEL label, and the ID is going to be called as in single quotes EMPLOYE, employee ID, and then we will have the name, right? What was next? Commission, COMM, com will be called as commission, COMMISSION, commission. Okay, so this is what the columns would be named as, then semicolon, enter. Now what next? Next one is data lines. So data lines will actually ask us to put all the data below it. So DATA LINES data lines, and after that I need to put all the data. So ID is equal to 1, and employee name would be RICKY, Ricky, and salary would be 2 3 whatever, LPA something something. Okay, so then 2, then we will have NIKHIL, Nikhil, then we will have 34, then we will have 3 as MANISHA, Manisha, then 43. So that's it, only 3 records I want. If you want more, you can have more as well. 4, this is JOHN, John, and salary is 12. So this is how we can do, and at the end just put a semicolon. That's it. Okay, so then you have to write run. Okay, so now RUN run, and literally you can run this. So we have F3 to run it, and it is getting executed now, and you can see that we have it here. So we have ID, name, salary, and commission. So everything is calculated and populated in a well manner over here. So very well manner it has been populated over here. Okay, so this is how what I did. I have created. Okay, So normally we call this as synthetic data. Okay, so what I have created is actually a synthetic data. So you can create like this. So just do it, and if you have done it, so you can share it in the in the comment box that yes, you have been able to create this particular data. And when you had clicked on run, so at that particular time in the output, you were able to see that the column has been populated, so that you can inform and mention. So if you are getting errors, so just take a pause and just look at where you have missed the semicolon, or you have written, let's say, spelling of name different here and spelling of name somewhere else different. So some small human errors, happen. So just take care of that. Just take care of that. Now let us move ahead. So this example we have seen, and now let us try to understand. So the output step, the data from the data set can be displayed with conditional output statement as well. So let us understand what are conditional output statements. So here proc print data is equal to temp, because already we have created this temp. So let me have it here. So proc print data is equal to what is the name which we have given, temp. So data is loaded, and what next do we need to do? Now we need to do where salary is greater than 700. So I will put where salary is in capital, salary is greater than I would write 30. Okay, 30, because we have very less salaries over here. And then we can run it. Okay, after that we can run it. So let me press F3 to run it, and you can see the output that we have the filtered data over here. You can see Nikhil and Manisha, only two basically outputs we are able to see. So this is called as filtering in SQL. We have done this, that how filtering is done. So below is example shows using where clause in the output to produce only few records from the data set, and we have executed, we have seen that. This is the whole program which I was writing in my, and here you can see in the screen as well. Now let's move ahead. The output of the above, the code is seen in the results tab. So here the means procedure and everything else, okay, which is given over here. Okay, so let's move ahead, and that is the end of the third chapter. Now we are on the fourth chapter, understanding the basic syntax. So let us try to understand the basic syntax. And before that, I'll be giving you a 1 minute break. So we will have 1 minute break over here. And in this 1 minute break, you can cover up the things which you have missed out. So you can quickly do the setup part, whatever you have missed out, just come to the same page so that you can execute along with me. All right, so let's have a 1 minute break, and then we will continue. All right, so the wait is over, the break is over. And I hope many of you who did not basically do the setup must be able to do it. So you can, just relax, and by getting relaxed, you can go along with me. Normally, I speak a little faster, but this is a recorded video. You can always go back and check it back again. So chapter 4, it is about basic syntax. Let us start with the basic syntax. I've taken a cup of milk for me. You can also enjoy coffee or something. Okay, so like other programming languages, SAS language has its own rules of syntax to create SAS programs, and there are three components. The first component is statements, second is variables, and then data sets. So statements, variables, and data sets. you may get this also as a MCQ question. So where you may be able to, you may get that which one of the following is not SAS component of a SAS program. Okay, so there the correct answers would also be there, and one or two maybe the wrong answers. Okay, so you need to remember that statements, variables, and data sets. So these are the three components. Now moving ahead, and let us now try to see here SAS statements. So SAS statements can start anywhere and end anywhere. A semicolon at the end of the last line marks the end of the statement. So semicolon we have discussed. Many SAS statements can be on the same line with each line ending with a semicolon. Space can be used to separate the components in SAS program statement. So spaces you can use, like it is not required you need to put comma or something. You just put a space. That means yes, they are two separate things. Now, SAS keywords are not case sensitive. They're not case sensitive. So small a and capital A are the same thing. Every SAS program must end with a run statement. So this is about the statements. I hope you are able to understand. Now let us move ahead about the variable names. So variable names, every programming has got some rules for the variable names. So here the variable names are, it can be maximum 32 character long, which is good enough. It cannot include blanks, which happens in many of the programming languages. It must start with the letter A through Z, not case sensitive, and it can also start with an underscore. Then it can include numbers, but not as a first character. Variable names are case insensitive. This is something we need to understand. So valid variable names we have are revenue underscore year, valid, max value, valid, underscore length, valid, invalid are miles per liter, because there's a space in between. Then rail for percentage. Percentage is a special character which cannot be there. 90 underscore high. 90 are the numeric which cannot be there in the beginning. So this is an example what we can have and what we cannot have. Okay, let's move ahead. And now here, if you see, the data statement marks are creation of new SAS dataset. Okay, so data sets. So data statements marks are creation of a new data set. So as soon as I write data, it actually creates a new data set which goes in the SAS memory. The rules for data set creation are a single word after data statement, single word. That means there shouldn't be space or something. It creates a temporary data set name, which means that the data set gets erased at the end of the session. So as soon as the session will get over, the data set will get erased. Next one is data set name can be prefixed with a library name, which makes it permanent data set. Okay. So are you clear, guys? Are you clear with what is permanent and what is temporary and what is the concept here? Let me know. Like if you're clear, say yes, clear with permanent and temporary data sets. Okay. Even here you can get some MCQs. All right. Yeah. So next thing is, if SAS dataset name is omitted, SAS then creates a temporary dataset with a name generated like data1, data2. So understand SAS is good enough in this particular thing. It gives some name from itself like data1, data2 if we miss to give name ourselves. Now the correct and incorrect examples. So data, temp data, data ABC, data new date is all correct. But here data library, yeah, so this is temporary. Now library 1 dot data one. So this is permanent. Data mylib dot new data, that is permanent. So this is the difference between temporary and permanent. Okay. So let's move ahead. And here we have, yeah. So SAS programs, data files, and the results of the programs are saved with various extensions in Windows. So we have a .sas file. It represents SAS code file, which can be edited using SAS editor or any text editor. Then we have .log file. It represents the SAS log file. It contains information such as errors, warnings, and dataset details for a submitted SAS program. Then next we have .mst or .html, which represents the result file. Then we have SAS 7 BDAT, okay, something like this. So it represents SAS data file, which contains SAS data, including the variables names, labels, and everything. So yeah, so that was all about extensions. Now comments. If you want to write a comment, so let us go here and in the window itself and try to write. So I have program one here. I'll just remove all this. So star, and I can write comment. So this is all comment which is being written. Okay, now, so you can see that these are all comments. And then after that, if you, yeah, just a second. So yes. So comments in SAS codes are specified in two ways. Below are the two formats. So star message semicolon type comment. So so a comment in the form of message cannot contain semicolon or unmasked quotation mark inside it. Okay. Also, there should not be any references to any macro statements inside such comments. So it can span multiple lines and can be of any length. So here you can see this is a comment. So let's have it. So for example, this is a comment. So here you can see. Okay. Now, multi-line, you can write star, 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 and at the end you can write asterisk. At the end you can write. Okay. That is multi-line comment. Now, moving ahead. Now, this is the end of the chapter. Now coming to the data sets part. And after this fifth chapter, we will directly jump to the time series forecasting because as I said, I would take around 40-50 minutes. It's almost 1 hour that we have got this. So till this, if you are familiar with SAS environment, you are able to work on it, you can write yes, able to work. Okay, because now the next part is also very simple, nothing complex to execute. And at the same time to understand, yes, you will have to pay attention. You will have to pay attention. Okay. So SAS data sets. The data is data that is available for to a SAS program for analysis is referred to as SAS data set. It is created using SAS data step. SAS can read a variety of files as its data sources like CSV, Excel, Access, SPSS, and also raw data. It also has many built-in data sources available for it. So here you can see this, the data set are called temporary data set if they are used by SAS program and then discarded after the session is run. But if it is stored permanently for future use, then it is called as permanent data set. All data sets are stored under specific library. So here also you can have some MCQ question, okay, which can talk about, okay, what is temporary data set and what is permanent data set. There can be a question. Okay, so here you can see under the libraries we have, so these data sets are already available in installed SAS software. They can be explored and used in formulating sample expressions for data analysis. To explore these data sets, go to libraries, my libraries, SAS help. On expanding it, you will see a list of names of all built-in data types available. Now, let's try to understand more. So there is some CARS cast data set. So do we need to see that libraries and my libraries and SAS help? And here we have ABCD cars. This cast data set is here. This is opened up. Okay. So this is what is data set. Okay. So let's move ahead. All right. Hmm. So this is about data sets. So there are so many inbuilt data sets we can work with to practice basically. Now we can scroll to the right, scroll bar in the bottom to explore all the columns and their values in the table. Yes, surely we can do. You can export your own files as data sets using import feature available in SAS Studio, but these files must be available in SAS server folders. So we have to upload the source data files to SAS folder by using the upload option on the server. That we can do. Yes. So let's move ahead and next click on, yeah. So this is the step to importing the external data and view the imported data. That's what you can do. So that is the end of the chapter 5. And now we are moving towards chapter 6, variables. So as I said, I'm not going to get into that because I'm directly going to cover up the time series part as of now. So let us go to time series. So this is time series. And I hope you guys are aware of time series. Can I get to know from any one of you what exactly is a time series before we begin? let's get some inputs from the audience. So I give you 1 minute's break where you can write in the comment box what exactly is time series. So 1 minute's break, and then we will start with this particular time series forecasting. All right, very good. So we have started to get the inputs, a specific way of analyzing a sequence sequence of data points collected, very good, over an interval of time using historical data to predict future. Very good, very good. Yes. So do you know what is logistic regression? What is regression? Maybe linear regression, multilinear regression. Any idea? Because normally we have regression to make predictions, and here we are talking about some specific way of analyzing sequence of data points. Okay, yes. So time series forecasting is all about sequential data with respect to time. For example, let's say I was able to score 10 marks yesterday, and today I was able to score 11, and then I was able to score, let's say, day after tomorrow, I was able to score 12. So every day there is an increase, and if I try to create a trend line, I'll be very much able to create a trend line for this particular thing. I'll be able to do that. Okay, so yes, so exactly, relation based. Good, yeah. So here we need to understand that time series is useful in weather forecasting, in sales, in marketing, in lead generation, in stocks, in finance, in banking. So at many places, time series is very, very useful, very important. Okay, relation between independent and dependent variable regression. Exactly, yes, that is regression. Good. Okay, so in this particular presentation, we are going to cover introduction to time series components, then AR and MA processes, ARIMA model, steps in time series modeling, non-stationarity and Dicker-Fuller test, then making data stationary, how to identify models using ACF and PSCF functions, how to identify models using minimum, information criteria matrix, MAPE, and training and testing data. So understand that these things, if you see that all these things are going to be a little complex for you. So have your pen and paper ready with you. Whatever you don't understand, make a note of it. You can Google it out, or you can do chat GPT and you can search on those particular terms, because I understand that may happen. But this is very, very, very important. And like whatsoever domain you are working in, time series is very important. And if you really know how to do time series analysis, you can do wonderful, maybe in stock trading, or maybe in forecasting, anything you are working upon. Okay, so understand, very interesting session this will be. Okay, so chapter 1 starts over here. So yeah, so let me stand, because sitting doesn't help me to gain that energy. So give me 5 seconds. All right, so let's continue. And now, yeah, I hope I should be audible enough. Okay, so the first chapter. So it is introduction to time series. Let us understand. So a time series is a data series consisting of several values over a time interval. Example, daily BSE Sensex closing point, weekly sales and monthly profit of a company, etc. So typically in a time series, it is assumed that value at any given point of time is a result of its historical values. So, for example, if the stock is 400 today, so it is resultant of some previous values. If the price of gold is, let's say, whatever, 80 something, so it is the value which has come from the previous values. That is what basically is assumed. So typically in a time series, it is assumed that the value at any given point of time is a result of its historical values. And this assumption is the basis of performing a time series analysis. And we are discussing ARIMA technique. ARIMA technique exploits the autocorrelation, that is the correlation of observations with its lags. You need to understand what exactly is a lag. Lag is basically, let's say, I bought an apple. The apple price yesterday was 10 rupees, and the apple price today is 12. So, if I want to know the lag price, one lag price, so today it is 12, and if I do lag by one, so one day, then it will be 10. So, this is called as lag. So, correlation of observation with its lags. Okay, previous lags means previous observations for forecasting. So if we talk mathematically, the equation would be something like Vt is equal to, Vt means value at time t. So Vt value at time t is equal to P Vt minus n, Vt minus n plus E. So it means that value at time t is a function of value at time n instance ago with an error, because it cannot be perfect. So there will be some error. There would be some noise or something. So we have a term over here which is error. So value at time t can depend on one or various lags of various order. Okay, so that is what basically we are trying to understand here, that value at time t is coming from, it is coming from what? It is coming from some value which was there previously at some time n. Okay, that way. Let us move ahead and try to understand more. So, example, suppose Mr. X starts his job in the year 2020 and his starting salary was $5,000 per month. Every year he is appraised and salary reached to a level of 20,000 per month in the year 2024. So his annual salary can be considered as time series. His annual salary can be considered as time series, and it is very much clear that the salary is function of previous year's salary. That means the function here is appraisal rating. So whatever appraisal rating is there, it is increasing the salary by that particular amount. I hope you have understood the fundamental concept of time series. If you have understood, you can write yes TS. Yes TS means yes, understood. Time series, yes TS, you can write, so that I get an input from you guys. Let's move ahead and now try to understand the components inside time series. So we have trend, we have seasonality, and we have random variation. So trend, seasonality, and random variation. Three components are there, and let us try to discuss all of them. So trend, seasonality, and random variation. Series could be constantly increasing or decreasing, or first decreasing for a considerable time period and then increasing. So understand, like you may see that series is constantly decreasing, series is constantly increasing. So something may happen, right? Constantly decreasing or constantly increasing. So this constant decrease and constant increase is called as trend. So trend is identified and then removed from the time series. Understand? Trend is identified and then trend is removed from the time series, because trend is a disturbing element. So it doesn't help us for prediction initially. Seasonality is the repeating pattern. Trend is the either constantly going up or coming down. That is trend. Seasonality is, okay, it goes up and down, up and down, up and down after certain time period. Okay, so seasonality is after certain time period, it goes up and then down. It goes up and then down. That is called as seasonality. Very important. What is trend? What is seasonality? Understand this particular thing. I'll draw here, okay, so that it becomes very clear to you, because these fundamentals sometimes become difficult. So if something goes like this, look at this particular line. So I hope that line is visible. I'm not sure whether it is visible or not. So I can see in the screen it is not visible. Okay, no problem. So what I will do is, let me clear all the drawings and close it. Okay, fine. So understand. So here you can see in this one. So it's not increasing, it's not decreasing, nothing is happening over here. So I will say I cannot see any kind of trend over here. There's no trend. Okay, but if you see this one, the second one, it is constantly increasing. This is also increasing. So there is a trend. There's a trend, linear trend is there. Okay, so that is called as trend. If you see that constantly increasing or constantly decreasing, the second and third one. The first one, if you see, so there is increase and decrease, increase and decrease, increase and decrease. So let's say if this increase and decrease is happening after every same set of time interval, same time interval, then I can say that yes, then I can say it is having seasonality. So season wise things are happening. Season wise things are happening. Seasonality basically means season wise things are happening. Okay, that is seasonality. Okay, fine. So repeating pattern with fixed period. Example, sales in festive seasons. So always sales in festive season goes up, goes higher. Okay. Sales of candies and sales of chocolates peaks in every October month and December month respectively in the year in the every year in US because of Christmas basically. Okay. Halloween and Christmas. The next one we have is random variation. Random variation is irregular component. So this is unexplained variation in the time series, which is totally random. So trend and seasonality, if you look at the time series, you are able to understand. But random variation. So now in this particular diagram we were seeing, this is random variation. I'm not able to understand like whether it is increasing, decreasing, what is the pattern over here. I'm not able to understand that pattern. So I will say that this is random. Okay, this is purely random. So this is unexplained variation in the time series, which is totally random, erratic movements that are not predictable because they do not follow any pattern. Earthquake is an example of it. Okay, that is random. Some terminologies also let us discuss. So these terminologies are autocorrelation, stationary series, white noise, and random walk. So let us try to understand these stationary series. Let us begin with that. All right. So stationary series is one whose mean and variance of the series is constant. Understand? Whose mean and variance of the series is constant over time. What does this mean? Stationary series, mean is constant and variance is constant over time. The series has to be stationary. Our requirement is the series has to be stationary in order to build time series with ARIMA. With ARIMA model, if we want to build, we need to have time series as stationary. Most of the time series are non-stationary, and if the time series is non-stationary, then what we need to do is at that particular time we have to make it stationary. Okay, we need to make it stationary, and which can be done with the help of detrending, and which can be done with the help of detrending and differencing. So why do we need a stationary? Because to calculate the expected value, we generally take mean across time intervals. And the mean across time intervals may make sense only when the expected value is same across those time periods. If the mean and population variance can vary, there is no point estimating by taking average across time. So moving averages, in ARIMA, we have MA as moving averages. So if mean is changing, if variation is changing, then basically there is no point in making predictions, and therefore we need a stationary series. That is the reason why do we need a stationary series. Then we have white noise. White noise process is one with a constant mean of 0. So here you can see with a constant mean of 0, a constant variance and no correlation. So there is no correlation between its values at different times. White noise series exhibit at very erratic, jumpy, unpredictable, behavior. So here you can see the diagram. So is it showing you something which is a trend, means something which is increasing or something which is decreasing? No. Here, with respect to time, there is no prediction which can be made, because it is all random, and therefore we call it as white noise. So white noise series exhibit a very erratic, jumpy, and unpredictable behavior since values are uncorrelated. Previous values do not help us to forecast future values. White noise series themselves are quite uninteresting from a forecasting standpoint. They are no linearly forecastable. So even these terminologies, remember, okay, we may have some MCQs related to them as well. Now let us try to understand autocorrelation. So autocorrelation refers to the correlation of time series with its own past values and future values. So with its own, we have discussed this, right? That is called as lagged correlation or serial correlation. It is also known as lagged correlation or serial correlation. That is also we can call autocorrelation as. Now, random walk. In layman's terms, it means that past data provides no information. Past data provides no information about the direction of future movements. So that is called as random walk. So we say that it is randomly walking because it is nowhere depending upon the past data. Okay, that is the basically meaning. So here yt is equal to yt minus 1. Okay, this is called as random walk. So it's called as random walk without drift model. It assumes that at each point in time, the time series merely takes a random step away from its last recorded position with steps whose mean value is 0. So it thinks that it takes some random step. It may be one, okay, a unit one drifting away from the original path. Okay, so therefore we call it as random walk without drift model. Then if the mean step size is some non-zero value, that is alpha, then the process is said to be random walk with the drift. This is without drift, and then it will be called as random walk with the drift, slow steady change, whose prediction equation is yt is equal to yt minus 1 plus alpha. So here you can see we have random walk. The first diagram, second one shows random walk with the drift, and third one is random walk with linear trend. That is what is the observation which we have. Now let's move ahead. ARIMA stands for auto regressive integrated moving average. It is also known as Box-Jenkins approach. It is one of the most popular techniques used for time series analysis forecasting purpose. So ARIMA, as its full form indicates, it has involves two components, but is one is autoregressive component and the other one is moving average component. So autoregressive component and moving average component, these are components here we have in ARIMA, autoregressive and moving average. Okay, so autoregressive, it implies relationship of a value of a series at a point of time with its own previous values. Okay, the same concept lag which we are discussing. Such relationship can exist with any order of lag. So in the diagram you can see sales, lag 2 sales. You can see. Okay, and understand. So by this time, you must have understood that we have month, we have sales. So month and sales, that is the actual data, exact data. But after month and sales, you can see lag sales. So lag sales means previous month's sales has been put in front of Feb. Then lag 2, in front of March, Jan sales have been put. This is lag. So lag is basically value at a previous point of time. Value at a previous point of time. It can have various orders such as what is shown in the table. It hints towards a pointed relationship. It hints towards a pointed relationship. So that is the autoregressive component. Moving average. It implies that the current deviation from mean depends on previous deviations. Once again, it implies that The current deviation from mean depends on the previous deviations. That's why we call it as moving average. Such relationship can exist with any number of lags which decides the order of moving average. So moving average has got a concept called as order of moving average, order of moving average. Okay. So order basically means lag. So one lag, two lag, three lag. So what is the lag? So that basically means the means order. Okay. That means order. Now let us move ahead. So yeah. So moving average is the average of consecutive values at various time periods. It can have various orders as shown in the table. Sales, then one is okay, lag one and lag two. Okay, that is how it is given over there. So okay, so this is basically getting the average of the from the previous data. So how much do you consider? So two blues are considered, two greens are considered, then three, you can see some color which is not orange, some color is there, then three yellows are there, so three are collected. So two can also be collected, three can also be collected. That is what we are trying to say, which basically defines the order, which defines the order. You have selected two, you have selected three, how many have you selected? So moving average is the average of consecutive values at various time periods. It can have various orders as shown in the table below. It hints towards a distributed relationship, as moving itself is a derivative of various lags. So moving average is itself considered as one of the most rudimentary methods of forecasting. So, but we have auto-regressive as well. So both auto-regressive, that is lag-based, and moving average component in conjunction are used by ARIMA techniques for forecasting time series. Now we would directly jump to ARIMA process in SAS. So therefore, this is the end of the chapter. Now the next chapter is steps in time series modeling. Okay, how's the Josh? We have 35 people still watching in. So how's the Josh in the room? Are we still actively listening? Are we awake and are we able to follow? Yeah, a quick response is most welcome. Can I get a quick response? Yes. How's the Josh? Are we all good to understand the steps in time series modeling? Yes or no? All right. So wonderful. Wonderful. Thanks a lot for giving me the response. Let's move ahead and yes, data file location. Library SAS help. I have already shown you that we have library here. Okay. So here you can see this is the library and we have cars, whatever, different data sets are there. So here there is no challenge. Okay, we have the data set. Okay, so let's move ahead and now data preparation step. So for ARIMA modeling, check if there is a variance that changes with time volatility for ARIMA. So variance is there, so check for it. And volatility should not be very high. That also we need to ensure. If the volatility is very high, we need to make it non-volatile. Check for stationary. A series should be stationary for performing ARIMA. If the data is non-stationary, we need to make it stationary. If seasonality is there or not, check that as well. So all these things we need to check. Let us move ahead. Now, you can keep on typing along with me if you can do that. Okay. So here you can see, as a matter of practice, we first plot time series and have a cursory look upon. It can be done directly in SAS using this piece of code. So let me take this up and go to the SAS window. Where is the SAS window? Here is the SAS window. And let me have server files. Let me have a new file. And here I can do. So run it. So you can see that this is the kind of plot we have got. Can you make some interpretation of this particular plot? Can you do some interpretation? Is there a trend? Do you see a trend? Write the answer. Do you see a seasonality? Write the answer. So do you see a trend or do you see a seasonality? Please do write answers over there in the comment box. Okay, let me check. Okay, fine. Yes. So here I can see, okay, I'll give you the whole interpretation as well. So this is the result which we can see in our presentation as well. You can see the result. So as a matter of practice, we first plot the time series and have a cursory look upon. It can be done directly in SAS. We use this particular piece of code, proc sgplot data is equal to SAS help.air. Series x is equal to date, y is equal to air, and we can see x is date and y is air. Run and quit. This is what we have done, and we have got the result. Moving ahead, it is clear from the chart. What is clear from the chart? It is clear from the chart above that the series of air is having an increasing trend and consistent pattern over time. The peaks are at constant time interval, which is indicative of presence of seasonality in the time series. This is non-stationary series for sure, and hence we would need to make it first stationary. Practically, ARIMA works well in case of such types of series which we first separate and capture the trend and seasonality component of the time, and we are left with a series of stationary series of, so this stationary series is forecasted using ARIMA, and then final forecasting incorporates the pre-captured trend and seasonality. So that is something we are able to understand from the diagram which is being plotted. We also need to understand here, we also need to understand, check the volatility. So how to check the volatility? We can check with the help of proc gplot data is equal to sas help.air and plot date with respect to air. So we can do that, and some this kind of data will be there on which the fan kind of structure has been drawn. So this shows that it is not parallel. It needs to be parallel actually. So it is not parallel. So that shows the presence of volatility, and therefore, uh, yes, we need to remove it. We need to remove it. Okay, that is something we need to do. Okay. So this piece of code we can put it into this piece of code we can put it into the SAS, and then we can work ahead. Okay, fine. So let me just take this up in the code window. Here we can keep on putting and just press F3. It'll execute. So this is the first output, first graph, and this is the second output, second graph. So it is not parallel, like it's fan-like. The blades are small and blades are larger at the end. Okay, it is that way. Okay, so now the next thing we have is, yes, so what is next thing? Now, treatment of volatility. So how it can be treated? Okay, volatility, how it can be treated. We need to make series non-volatile and move ahead. We would start transformation of air series and remove volatility. Generally a hit and trial method, but we will not be using hit and trial method. We will be using Box-Cox transformation, because Box-Cox transformation will help us to recommend with the help of the lambda value that what should we do in order to remove the volatility. So let's basically execute this, which is proc transreg data. This one, I'm copying this and putting it over here. And let us run it. Okay, so here we have the output 1, output 2, and here we have some values. So this particular pillar, you can see it is near lambda 0. Let us go back here and try to understand what exactly is happening here. So you get the following plot along with lambda, which is 0, lambda value, which is 0. And if you go to the common Box-Cox transformation for value 0, we have a formula which is called as log y. Okay, and let us follow that. This is what is the thought process and understanding. Okay. So box-Cox transformation can be used to help you out and recommend the suitable transformation. You'll get the following plot with lambda value, which is 0 in this case. Now, based on this lambda value, you can, yes, you can decide the transformation. So log y is the transformation. Look at this common box-Cox transformation table. So we are getting the value 0. Therefore, we will apply log y. And let us apply log y. Why not? Okay, so here we'll apply log y. Yeah, so here and execute it. Okay, fine. Let's go back. All right, yeah. So here we can see that we can check the volatility again of the transformed series. So this is transformed. If you want to check, you can check for that as well. For example, so this one, let me put it over here. And okay, now let me run it. So look at this. Observe this one. Okay, this image, this one, observe this and observe this image. Is there any change? Do you see any change in both of them? Here you can see it is very narrow and it is very widespread. Here it is this much, here also that much, little bit here and there, but similar, right? Yeah, so this is what I wanted to bring in, remove the volatility. Now let's move ahead. So now on transformed series, we can check whether series is stationary or non-stationary. For performing ARIMA, series should be stationary. If it is not stationary, then we'll have to apply. Okay. Now, rather than identifying the series stationarity visually, as we have done in step number 1, we would use augmented Dickey-Fuller unit ratio test. So these are also the services which it gives. So now here, what we will do is, rather than identifying the series stationarity visually, as we have done in step 1, now we will use augmented Dicker-Fuller ratio test, unit ratio test for the same. Now, this test is going to help us to understand what is null hypothesis and what is alternate hypothesis. That is what it does. So the Dickey-Fuller test is used to test the null hypothesis that the time series exhibits a lag d unit root against the alternative of stationarity. So null hypothesis says non-stationary, alternative hypothesis says stationary. There are three types by which you can calculate test statistics of Dickey-Fuller test. One is zero mean, second is single mean, third is trend. Zero mean basically means no intercept, series is a random walk without drift. Single mean includes intercept, series is a random walk with drift. Trend means includes intercept, and trend series is a random walk with linear trend. So understand these are different scenarios by which you can understand. Okay. Now, there are drawbacks also of this particular test. What is the drawback? Yeah, so it is uncertainty about what test version to use, like which one, intercept to be included or not, time trend to be included or not. So that is the difficulty over here. Okay, whether to include them or not to include them. That is the difficulty over here. So what to do? So inappropriate exclusion or inclusion of these terms substantially affects the test reliability. That is a problem. If you add or even remove, and that is not done properly, then that basically makes up loss. So using prior knowledge, for instance, as a result of visual inspection of a given time series about whether the intercept and time trend should be included is the most recommended way of overcome difficulty, which is mentioned. So what we will do is we will have this one. Let's have it here in the code area. Okay. So here you can see this is the result. And let me show you the result with the help of presentation and try to understand. This is the result you can see. Okay. So what is important? So we have augmented Dickey-Fuller test. We have autocorrelation function, ACF. So if you see that the highest peak with first lag and then local peak at 12 lag, in the ACF chart, we can see that there is a shaded or bounded region. So all the data should come under that bounded region. Okay, that is the basically rule. Now, next thing is the tau statistic. So check the tau statistics, that is PR less than tau, that should be there. And p value should be less than 0.01 for stationary. So here you can see the values which are very high. If the values will remain so high, then what is going to happen? We need to declare that it is non-stationary. So looking at both of them, the augmented Dickey-Fuller test result and autocorrelation, we can say that the series is non-stationary and we have to make it stationary. So post establishing the known stationarity of the series, we need to make a series stationary. Differencing process is used for making series stationary. Differencing, transformation. So what is differencing? Transformation of the series to a new time series where the values are differences between the consecutive values. That is differencing. So here you can see differencing orders. First order dxt xt minus xt minus 1. Second order dxt minus 1. So we can identify the differencing with the help of formula being applied. It is it is unlikely that more than two differencing orders would be ever required. So as per the understanding and research. So here you can see that autocorrelation check white noise. We decided the orders for differencing required. A heat map has been used with the help of a chat. Uh, yes. So a heat map has been using Excel. So this is basically this is made using an Excel. But if you see, it doesn't give us any kind of heat maps. It gives us maps, but it is not a heat map. Okay. Fine. So the first row of the above autocorrelation matrix shows that correlation of time series with first to sixth lags. Second row shows 7th to 12th lag, and so on. Then the same is visible in ACF chart. Same thing. So what exactly do we need to do? Now we have to work on making it stationary. So how to do that? Now here we have check seasonality. Okay, fine. So here if you see, okay, so that window came up. Yeah. So here if you see that the same table is being displayed over here. The same table is being displayed over here. You can see. Okay. And the same table we can see over here. Now, for seasonality, so highest correlation with the first lag indicates towards the presence of trend. So highest correlation with first lag. Here you can see highest correlation with first lag. Okay, so it shows presence of trend. And with 12th lag indicates annual seasonality. Okay, so trend is also there and seasonality is also there. Hence, we need to do differencing at first and 12th orders. And therefore, this code does the same thing. At first and 12th order, it shows the removal of these components. So let me go ahead, and here we will have, okay, and run it. Okay, so yeah, here we have more outputs over here, and we will try to understand them. Hmm. So the tau statistics, which says that the p-value should be less than 0.05, then we can say that the data is stationary at 5% level of significance. That is what we can say. We expect it to be less than 0.01. Okay, so here first order differencing removes the trend and second order differencing removes the seasonality that we have discussed. Now, what is the next step? The next step is split the data into training and validation. So we have removed, right? We have removed the trend and seasonality. Now, data set needs to be split into training and test. So let's have that. So data training validation. So data is going to get divided. So let it get divided. This is time series, so you can understand we cannot have random sampling over here. But what we can do is we can have like whatever if date greater than equal to Jan 1960, then output to validation. Otherwise, everything will be there in the training. This is what we have done. Okay, so now the chapter is model identification and forecasting, because once we train, then after that we have model identification and forecasting. In this, we need to understand a couple of things, and they are ARIMA auto-regressive integrated moving averages model is usually denoted by notation ARIMA PDQ. So it has got ARIMA PDQ. So we can have it ARP and ID and moving averages Q. That is how it'll better able to make us understand. So P is order of auto regression, individual values of time series that can be described by linear models based on preceding observations. So that is order of auto correlation, auto regression basically. Next one is D, order of differencing, number of times the data to be difference from the to become stationary, that is D. Then Q is order of moving average, number of lagged forecast errors in the prediction equation, past estimation for forecasting errors and taken into account when estimating the next time series value. So Q is basically order of moving averages, which is a different thing. Now let's move ahead and understand that there can be so many models which can be created just by changing these values. So you can see that simple exponential smoothing ARIMA holds exponential smoothing ARIMA, white noise ARIMA. So white noise ARIMA is there, random walk is there. The values are changing. The values are changing. Okay, random walk with no constant, random walk with the drift, random, then auto regression, moving averages. Okay. So how to identify? We can use ACF and PACF functions, or we can use minimum information criteria. So one we can use out of them. So one we are using here, so autocorrelation function, it is a function. The autocorrelation function, what does it do? The autocorrelation function actually, yes, it's a correlation coefficient. What kind of, however, instead of correlation between two different variables, the correlation is between two values of the same variable at different time. One is xt and one is xt minus h. That is what basically autocorrelation function. Now, PACF, that is partial autocorrelation function. For a time series, partial autocorrelation between xt and xt minus h is defined as the conditional correlation between xt and xh, conditional on xt minus h plus 1 till xt minus 1, the set of observations that can come between the time points t and t minus h. That is called as partial autocorrelation. Let's move ahead. And now here you can see P stands for PACF, that is partial auto correlation function. Q stands for autocorrelation function. And here you can see that the bounded region as at first bar is crossing bound, hence Q, the first bar is crossing, Q is equal to 1 should be considered because it acts as moving average component. And then in the second one, you can see as the first lag bar is crossing the bound, hence P is equal to 1 should be considered. It acts as auto-regressive component. So that is what we need to do, this much of analysis. Now, the next thing is, yes, so the model identification obviously we are doing. So here the next thing which we have is that proc arima. We have already done the split of the data. So we will do the forecasting from here, and let us do the forecasting. And let me press F3, and it is going to bring up the result. So here you can see that it is bringing all the results. Let me go down and see. Yes, so this is the forecasts of log air. Okay, it has given to us. This is the forecasting. Okay, yes, so coming back, so ARIMA procedure we have done, and we used ACF, PACF. We did not use minimum information criteria matrix. Okay, we have used ACF and PACF as of now. Okay, so here what we did is uh, identify var is equal to variable y, which is periods of differencing, estimate p order of autoregression, q order of moving average, and then where variable y is modeled as ARIMA, P dq, where P is equal to order of autoregression, D is order of differencing, and yes, and determined from periods of differencing, and Q auto order of moving averages. Okay, so therefore we have set their values log air 112 and P is equal to 1, Q is equal to 1. We have set those values and it has brought us the result. So that's it. Okay, using these identified P and Q values, we run a RIMA model, which gives us the forecasting. And that's the end of the session. So now in another 5 minutes, the quiz will be open and you can fill the quiz so that you are eligible for the certificates. And thanks a lot for watching in. It's almost 2 hours you have been with us. Thank you. Thanks a lot. You can share this video with others also. And yes, obviously you can subscribe to our channel and ask your friends to do the same thing. And you can let us know any feedbacks you have, anything, any use case you want. We will come up with those things and we will explain. So wait for the next Saturday. We have something very special for the upcoming Saturday. If you want to suggest something, please do that. Once again, thank you very much and keep doing well, keep learning, keep growing. Thank you.